So good evening, everyone, and welcome. My name is Garrett. I'm the Executive Director of CanConnect19. I want to thank you all for taking the time to join us for tonight's presentation, which is live blood analysis and what can we see in our blood. And it's hosted by Dr. Wendi Roscoe. For those who may be new to CanConnect19, we are a Canadian peer-led support network for individuals living with long COVID, vaccine injury, and other complex chronic health challenges that may have arisen as a result of COVID vaccines. Our mission is simple, is to ensure that people feel seen, heard, and supported and connected to educational resources and community. So one of the ways we do that is through events like this, where we bring together knowledgeable practitioners and experts to share information, answer questions, and help people better understand their health. So tonight's presenter is Dr. Wendi Roscoe. She's become a familiar and trusted voice within our community for sure. Many of you have attended her previous presentations on spike protein detox, heavy metals and halides, and other topics related to chronic illness and recovery. So Dr. Wendi has a gift for taking complex scientific concepts and making them understandable and actionable for everyday people. So this evening, she'll be discussing live blood analysis and exploring questions such as what kind of anomalies can be observed in blood? Can blood provide clues about vaccine injury? Why did some people experience severe reactions to COVID-19 vaccines while others did not? And what does the evidence tell us about nattokinase, blood clotting, and spike proteins?
I have been doing live blood analysis basically since the pandemic because I don't know if you guys have heard about, a few people like Dr. Anna Mahelsha and Dr. David Nixon who started talking about nanotechnology being in people's blood after the vaccines. And so I started working with a group in the US, and they have wonderfully donated a microscope for me to use and do research for them. If you've heard of Healing for the Ages with Dr. Brian Ardis, Henry Ely, Ed Group, and Jana Schmidt, that group. So this is my microscope back here. And so it's probably one of the most amazing microscopes in the whole entire world. I would never be able to afford it on my own. So it's been wonderful to have this microscope to be able to look at what I can see in people's blood. And so I've been doing experiments for several years now, since 2022. And so 4 years of looking at many different people's blood. And so I'm going to share with you those things that I've been finding predominantly. So what I want to kind of talk about, what can we see? So I'm going to show you some cool images and I have a dark field and a bright field microscope, so I'll show you a bit of both. And I have some video and images so you can see like super zoomed in the kinds of things that we can see in the microscope. Can we see spike proteins? So I'm going to show you how big a spike protein is, how big any protein is, and what we can actually see in the microscope. Moving dots, this became a whole big, huge thing because of the vaccines and, the people that were doing live blood analysis. Also, just to throw in there, I did do a program, a live blood analysis 12-week program with Dr. Oker, who is kind of world renowned for teaching about live blood analysis. He's from the UK and it was an online program. So I did that program. That's how I started learning about all of this stuff. Previous to that, I did research. So I've used microscopes for 15 years, but it's only been the last 4 years that I've been looking at blood. And so we'll talk a little bit about how big is nanotechnology and like what are the moving dots. So it's kind of cool. Can we tell if somebody is vaccinated by looking at their blood? What kind of factors can affect your blood? So if you decide to go to a live blood analyst, what are some things that you should think about? And then I'm going to show you some cool stuff about electromagnetic fields. So if you use your phone a lot, or Bluetooth, or Bluetooth headphones or smart devices, Wi-Fi, all that kind of stuff, it definitely affects our blood. And I'll show you what that looks like. And then a few sort of theories, because of course nobody can prove anything, but why did some people have major reactions to the vaccines and other people didn't? So I have some ideas about that. And then I wanted to talk about nattokinase and other proteolytic enzymes as a supplement because clotting is a huge factor that seems to be very common in people that have had issues with the COVID vaccines. So when we look at what can we see, how big are things? And so when we look in a microscope, let me just get my pen tool up here. Okay, let's start with a human hair so you can see how big a hair is. You can visually see that. That's about a millimeter, and there are 1,000 micrometers in 1 millimeter. So if you divide 1 millimeter into 1,000 pieces, then you have a micrometer. And so a micrometer in the microscope actually looks like, decently big. Like you can see a micrometer in the microscope. So in a light microscope, which is the microscopes that live blood analysts use, dark field and bright field are light microscopes. And we can see around a half of a micron up to a millimeter in the microscope. So we can't see smaller than that. And if you want to see smaller than that, then you need an electron microscope. So things that we can see in a microscope, we can see red blood cells, we can see white blood cells, we can see blood clots. And I'll show you what those look like. We can see bacteria, but we can't see viruses. We can't see antibodies. We cannot see spike proteins. We can't see DNA, right? These things are way, way too small to see. And I know that there are live blood analysts out there that are telling people that they can see spike proteins, and that is impossible. Okay, so just so you know that. We can see about 500 nanometers. So there's 1,000 micrometers in a millimeter. There's 1,000 nanometers in 1 micrometer. Okay, so that's like beyond small. It's like trying to imagine like $1 trillion. Like it's so small. Okay, so now we have moving dots. So these are the things that, you know, in between the red blood cells, the plasma area, which is just the fluid in our blood, should look clear in the microscope, but sometimes we see these little dot things that are kind of moving around. Now, there's a bunch of different things that this can be, but it is not nanotechnology. Okay, so this was another thing that was like really hugely talked about for a period of time, is that there's nanotechnology in people's blood. If there is, we can't see it with the microscope. So back here to how big can we see things? So we can see to here. We can see on this side, red blood cells, bacteria. We can see like replicating chromosomes, cells, right? But we can't see. So down here, this is nanotechnology. Nanotechnology is in the 1 to 10, like nanometer, tiny, tiny, impossible to see with a microscope. So if it's there, we can't see it. So when we see these moving dots, the most common thing that they are is called chylomicrons, which is like a blob of fat. When we eat food and we absorb fats in our diet, fats don't dissolve in water. Just put some olive oil in water and shake it, and you'll see all kinds of little bubbles. So fat has to travel through our blood as kind of like little packaged blobs of fat. And those are called chylomicrons. And that will happen every time we eat food. But there's other reasons why we can have these moving lipids or fats in our blood. And some of them, like, so when we do live blood analysis, I always have people fast for at least 12 hours so that I'm not just seeing all these moving dots from your, toast and butter in the morning, right? So we want to be fasted when we look at your blood. And there will be some moving dots still because we'll have like endogenous lipids. Our liver is always breaking things down and pulling nutrients into the blood during periods of fasting so that we can always still make energy. Sometimes, though, fasted people will have tons of moving dots, and it's like, what are these things? And so this was the whole conundrum after the pandemic because it seemed like people that had symptoms of inflammation would have more of these moving dots. So what were they? So I don't think that they were nanotechnology. I think that they are antigen antibody complexes. So a lot of the reactions that people had from the shots involve an autoimmune reaction. So when we make antibodies and they bind with antigens, those complexes can be big enough to see and they'll look like moving dots. We can also see little bits of fibrin, and fibrin is this sort of spider webby sticky stuff that becomes a blood clot. And that can be broken up into little chunks and they can move around and look like moving dots, and we can see those. We can also see exosomes. Exosomes are a really cool thing. I'm going to do a whole talk actually, one of these days. The next talk I do is going to be about exosomes because it's significant to shedding. And so I'm not going to go into huge detail about it now, but they're little vesicle things that our cells can make, and we can see those in the blood. And then it can be bits of red blood cell membrane debris because our membranes are lipids. And so if our red blood cells are kind of dying, then we'll see chunks of membrane. This is a chart. If anyone is interested in these details, you can also, I'll give you my email at the end, and you can email me if you want a copy of my slides. I'm more than happy to share these, but I won't go into the super details about the movement. That's more for like a live blood analyst to kind of pay attention to so you can tell the difference. So let me show you a video here. Wait, I want to. Oh, there we go. This, I just took a quick video with my phone, but you can see this is bright field and you can see these little dots. These are the moving dots that I'm talking about. So this is a normal amount of moving dots fasted. So this, I just looked at my own blood. There's some clotting there because it sat there for a long time. I don't normally have that much clotting. But so that's just to give you an idea of how many kind of dots you would see in a bright field microscope in a fasted person. And then in the dark field, we actually see a whole lot more. So a lot, like the moving dots are significantly more visible. So this is still me before eating, but this is what it looks like in the dark field. So this is kind of a normal background level of lipids, assuming I don't have some inflammatory stuff going on, which is possible. I mean, there's a lot of toxins in the world, and it's definitely difficult to be perfect. But just to show you again, these little dots are always kind of in the background moving around. Now, this is what chylomicrons look like after eating. See, now you're going to see way more moving dots. So this is chylomicrons. This is after eating, and then you're going to see lots and lots of these dots. Now, if we see huge amounts of these moving dots while fasted, then it's going to be some other reason that I was just talking about: exosomes, cell debris, antibody complexes. And it usually shows up if you have inflammatory kinds of symptoms. And I see this in vaccinated, unvaccinated, all kinds of people. So it's not specific to vaccinated people. So if you ever did want to go to a live blood analyst, if you're not nearby me, because I would be the best one to go and see, of course, if you're in this area. But if you go to another one, there's a few different things that not all live blood analysts tell their clients to do. I'm in a like a global live blood analyst like group where we share images and talk about stuff all the time. Um, these are really important things to make sure that you do. You need to fast for at least 12 hours before so that you know if the moving dots are simply chylomicrons or if there's some other weird thing going on. So you want to be fasted. And then other things can make your blood look bad temporarily. And so I have found, and it's actually good to know this stuff because then you don't want to do this all the time, but sugar and alcohol actually can make your blood look fairly terrible for about 24 hours. So if you have sugar and alcohol every single day, then there's going to be inflammatory kind of stuff going on in your blood every single day. So when you are going to look at your blood, you want to see like your normal baseline. If your normal baseline is sugar and alcohol every day, then do that so you can see what your blood looks like. Also, doing crazy workouts. So, exercise is amazing, but if you do like a super hard workout, like you decide to run 10K for the first time, or you go to the gym and you lift like super heavy weights, your blood is going to look really bad. It's going to cause inflammation. But that kind of inflammation is like a transient inflammation. It's not like a background chronic disease kind of inflammation, which is what I'm interested in seeing. So I have people avoid these things. So I know that if I see inflammation, it's not because of something that's just because you had a hard workout, right? And then same with any kind of stressful thing, like going to the dentist, having a deep fascia massage, you know, some people do cupping or like any of those kinds of things that are going to be inflammatory for a period of time. Don't do those right before looking at your blood. You also want to make sure that you are not dehydrated. So have a nice big glass of water about an hour beforehand. And then you also want to avoid touching your phone. And ideally, you want to do some grounding. And I'll talk about the EMF and the grounding stuff a little bit more in a minute. So I'll just show you some pictures and some might be videos of some clients that I've had and what blood can look like. And, unvaccinated people have health issues and they can have pretty terrible looking blood too. And sometimes I have people that had a vaccine and their blood looks totally great. Sometimes people look bad for a period of time and then they make lifestyle and diet changes and then their blood can start to look really good. So the blood is a really cool way to see what's kind of going on inside of your body. This example here is showing red blood cells that are stacked together, and this is a formation we call rouleau, where it looks like stacks of coins. Your red blood cells should always be separate and not clumped together. And then you can see all this sort of spider webby material in between the cells. And you can see this is a fasted person, but look at all those moving dots, right? So this is an example of huge amounts of inflammation with a lot of clotting going on. The other thing that I wanted to point out, and I'll just do this quickly, I'll start the video. I think this one is a little bit longer, but when we take a drop of blood and we put it on the slide and the blood smears out. So I put a little drop on a cover slip and then I lay the cover slip on a slide. And then as the blood spreads, the outer portion of the blood sample spreads faster than the inner part. So as the blood smears across the slide, the outer part of the sample is going to look awful all the time. So we have what's called the working area of the sample, which is the part that's going to be most logically about what's happening inside your body. So you don't want, like, so if your live blood analyst, shows you something that looks like completely horrible, then just ask them where they are on the slide. So this is like, decently good looking cells. But now as I'm getting to the edge of the sample, you can see that the red blood cells are starting to look all warped and then they're going to start to look all clumped and they're all bumpy. And as we get more and more to the edge, the cells are just completely clumped. And then there's the edge of the sample. So we need to be in the area of the sample that's logical. So just so you know that, we can probably find any part of the slide that can look really bad. But we have to be in the right area of the slide. We need to be in the middle of the sample and not at the edge of the sample. So that's a really huge factor that some live blood analysts aren't really aware of. Now, the EMF pattern, this is a pattern that I see all the time. So people that have their phone in their hand all the time, even if for this day they decide to keep it off of their body, this pattern shows up when people have too much connection to smart devices like phones or Bluetooth or iPads or sport watches or smart things that monitor you, like, even blood sugar monitors that are connected to EMF, sometimes hearing aids that are connected, like anything you can control with a phone that's on your body is electromagnetic fields, and those frequencies affect our cells. And they affect our cells in the sense of changing the charge of the cell. So the outside of all red blood cells should be negative, and we regulate the charge by ions moving in or out and how our cells are surrounded by fluid. And that is affected by how much salt and things that we eat. And but our body generally is like really good at regulating ions, or we would have symptoms. And so when we have a lot of exposure to EMF, then it alters the ion concentrations inside and out of the cell, and it changes the charge. And then the red blood cells become positive and negative, and they start attracting to each other. So this is the sort of initial stage where it they're just kind of clicking together, but then they can fully turn into those rouleau kinds of things. So there's a spectrum of how much the EMF is affecting those cells. Is that a video? No, that's a picture. So then this is zoomed in a little bit more, and you can see the red blood cells are all kind of forming, I call it a honeycomb pattern. And the cool thing about this is that it it depends on the amount of exposure, but usually if you put your phone down and then you are barefoot outside on the grass for 20 minutes, this goes away, which is really cool because when we ground, the earth has a lot of free electrons that can come into our body and help deal with oxidative stress. And I talk lots about oxidative stress, by the way, in my heavy metal course. Um, Lots of super cool information in that course, just in general about inflammation and oxidative stress. A lot of toxins cause oxidative stress, and EMF is one of them. So I consider EMF to be a type of toxin, just like spike proteins and mercury and pesticides and plastic. They're all just types of toxins, and they all can have an effect on our immune system, our cellular function, and they all generally cause a form of inflammation. And also interesting on this slide is this shiny blue object here, which I believe is microplastic. I see a lot of microplastic in people that, either use plastic containers for heating up food, drink out of water bottles frequently, have a plastic, you know, drinking cup. Um, and then, surprisingly, there's one of the main ways that we're exposed to plastic is through inhalation of dust and lint, because fabric on your couch, your carpet, your clothing, if it's polyester or acrylic, that's all plastic. And so then those fibers, are in the air, and then we breathe them, and then they can get into our blood. And so we can consume them with our food or we can breathe them in. Either way, I see a lot of these shiny objects in people's blood, which other scientists confirm is likely plastic that never used to exist in blood before. Okay, so I have a bunch of clients. I just use their first name, so you don't really know who they are. But this is a client who was addicted to his phone, constantly scrolling, constantly like just couldn't ever put his phone down. If it wasn't in his hand, it was in his pocket. So basically connected to his body all the time. So his blood showed this EMF pattern. And he was young, he was a teenager. And so I made him ground for 20 minutes. And then we looked at his blood again, and his red blood cells started coming apart. It's still not perfect. There's other things going on, but grounding helps to break up that oxidative stress that makes the red blood cells all attracted and sticking to each other. And when the red blood cells are sticking to each other, they can't function properly. They need to carry oxygen and move nutrients around and, get into small capillaries, and they can't if they're all clumped up. Now, I want to show you a bunch of different pictures of a range of anomalies that we can see in the blood in vaccinated people and unvaccinated people. And the point of this part is to show you that we can't tell the difference between who's vaccinated and who's not vaccinated by looking at the blood, which some very vocal online live blood analysts were talking about. It's not possible to know because unvaccinated people have oxidative stress and inflammation and blood clots and all the same kind of things if they're, not taking care of themselves or they have like poor lifestyle habits or exposed to a lot of toxins or mold or whatever. So here is one client, a severe vaccine injured client that had lots of rouleau. So the red blood cells were all clumping together. Now, rouleau can happen because of EMF, but it can happen for lots of reasons. Anytime there's a high amount of inflammation, the red blood cells can become damaged and they'll clump and cluster into these rouleau formations. And then the other important thing to note is the clotting. So all this fibrin and then these areas here where there's platelets aggregating and this fibrin is forming. So when there are microclots, so this is tiny because remember, each one of these red blood cells is about 8 micrometers in size. So this dot here, that little dot, that's probably, well, that's a big dot now. Um, let's say that dot is probably like 500 nanometers, and my big dot here is probably like 2 micrometers, right? So this is the kind of size range that we're in. And so we can see these little microclots, but if there's a lot of microclotting, then that can indicate that there's a potential for larger clots that can cause heart attacks and strokes or deep vein thrombosis kind of things. But what's really cool is this vaccinated person has been doing a lot of work for a couple of years, improving all kinds of things. And so then this vaccinated person has beautiful blood. So it is possible to make changes no matter what the toxic exposure. Some people have all kinds of inflammation and oxidative stress because of mold exposure or because they live near power lines or, there's lots of reasons why people can have severe symptoms and I think of vaccine injury with the spike proteins and the lipid nanoparticles. They're a form of a toxic substance that can trigger this cascade of reactions in different people. And everybody reacts differently to different kinds of toxins, which is what makes it so difficult. So figuring out everybody's individual sensitivities and intolerances is important. So here, okay, so yeah, so Andy, this unvaxxed, but had blood sugar stuff, had high blood lipids, high LDLs, had leaky gut stuff going on, lots of bloating, digestive issues, and inflammation. And so what's cool here is these fibers. So it is extremely common to see these fibers in people's blood. Now, there were live blood analysts talking globally about this being self-assembling nanotechnology, and that is not true. These fibers have been seen in people's blood for decades and decades and decades. And there's multiple books showing images from the 40s and the 50s of people having fibers in their blood. So when I see fibers in the blood, this indicates to me leaky gut because we have in our intestines where we're absorbing our nutrients, we only have a single layer of cells as the barrier between the food we're digesting and then those broken down molecules getting into our blood. So if that layer of cells in our gut is damaged, then bigger things can get into the blood that shouldn't get in there. This is why leaky gut and digestive issues can be such a huge contributor to overall inflammation. So if you have leaky gut, it can make your arthritis worse because you're getting foreign weird things going into your blood that shouldn't be there. And this is activating the immune system. And then the immune system activates like other immune cells in your whole body. And you can see in this image, which is really cool, all of these big white cells. These are immune cells. And you can see that Andy's immune cells know that this foreign fiber shouldn't be there, and his immune cells are actually attacking it. So this is a beautiful example of inflammation, right? So it's inflammation is when there's something going on, tissue damage, a toxic molecule, infectious organism, something that shouldn't be there that activates your immune system to try to attack things to get rid of it. But when your immune system does that, it can sometimes overreact and then damages healthy cells, and that can give us symptoms. Here's another severely vaccine injured person. Um, Lots of microclotting. So these are all micro blood clots. And micro blood clots, these two things here are immune cells. And then you can see the red blood cells. There's lots of wonky, weird ones. They should all be round, but sometimes the red blood cells have all these kind of funny deformed shapes. And that's showing that the membrane, the lipid membrane, which is kind of like an olive oil kind of substance sort of structure, and that can become oxidized and damaged by the immune system and by toxic things. And so when we see all of these red blood cells being damaged, we know that there's inflammation going on. And yeah, he had a lot of autoimmune and skin and gut stuff happening. And then we have Kevin who had a big giant cholesterol molecule. So this was a vaccine injured person, but I see these cholesterol molecules in all kinds of people. So this is not a vaccine specific kind of thing. I see it in unvaxxed as well. This is this is contributing to so the oxidative stress in the blood damages the lipids that are circulating in the blood. And then it can cause this clumping. And cholesterol crystals have this unique, like there's always a straight edge. So if you look at any live blood analysis image of a cholesterol molecule, it always has this kind of a shape. And this indicates that the lipids in the blood are being damaged or oxidized. And there's lots of reasons why fats can be damaged. It can be because of consuming processed foods is one of the hugest ones. So eating packaged foods with trans fat and preservatives and artificial colors and flavors and MSG and all that kind of stuff. That's all toxic stuff. And that's going to damage the circulating lipids. This is the kind of thing that is a risk factor for cardiovascular disease. So we want to decrease the oxidation of the lipids, right? So changing the diet, eat plants and animals. Colorful plants are great polyphenols that help decrease the lipid damage that happens in the blood, and then avoiding toxic things like smoking and alcohol and sugar and EMF and power lines and pesticides and all that kind of stuff, right? Any kind of a toxin can damage our circulating lipids. But for cholesterol and cardiovascular issues, the most common issue is really about the diet or bad habits like smoking or drinking too much. Then we have a phone addict whose blood, pretty much even with some grounding, always has this rouleau formation. Um, so the red blood cells are really charged. And so, the more extensively you're holding your phone, like if you're always on your phone or it's in your pocket and then you fall asleep and it's on your head, like it's just keep in mind that that's really damaging to the cells. Those voltage frequencies affect our cellular voltage. And then we have, oh, okay, so this was a cool experiment. This isn't even about EMF. So grounding is great for EMF exposure and decreasing oxidative stress, but it's good in general for decreasing inflammation. And so Anna, before she walked around barefoot outside for 20 minutes, had lots of micro clotting, these red arrows, and then the fibrin formation. So all these red arrows are micro clots. The blue arrows are showing healthy, active immune cells, but she had a lot of immune cells. And then this yellow arrow is showing a basophil, which is involved in allergic reactions and histamine. So sometimes people can actually have like allergy kind of reactions to some kind of toxins, like molds or EMF or even spike proteins. It can trigger allergic kind of reactions. And so after grounding, that inflammation decreased. And this inflammation wasn't cell phone induced. So grounding is really good for decreasing all kinds of inflammation. So while the summer is nice and warm, except for maybe where Garrett lives, you want to try to spend some time outside barefoot, getting all those wonderful electrons from the earth. Unvaxxed person with many health issues. So again, you can see that there's lots of microclotting, lots of fibrin. The red blood cells are very damaged. So it's not just vaccine injured that have health issues. Oh, this one is interesting. So living beside a 5G tower um, is not fun. So his red blood cells always looked like they were exploding. And about 2 years after he bought the house, which was right beside a 5G tower, he was diagnosed with cancer. And luckily, that's in remission now. What he did, because we suspect that tower was probably a primary factor involved in triggering the cancer. There might have been other things going on before, but the 5G tower, certainly wasn't helping anything. So what he did was he put aluminum all over the wall of the house that faced the tower to act like a shield. And he did a bunch of other things as well, but his blood got better, which was really cool. So also, so just, if you're buying a new house, just look around for power lines and 5G towers and, you know, maybe not a good idea to live that close to those things. So then, why did some people have a super reaction to the vaccine and other people seem to be totally fine? So I have a few theories, but we don't really know. But there are different batches. There were different batches, and I think that it's fairly well known that Pfizer for sure had various batches in the beginning of the vaccine rollouts where there was different concentrations. There was more DNA contamination. There was more DNA plasmid integration. So there were batches that were definitely worse than other batches. So that's an unfortunate circumstance for the people that got the batches that were the most detrimental. But there's also some genetics, and because a lot of the vaccine injury symptoms, like the blood clots, chronic inflammation, mast cell activation, autonomic dysregulation, POTS, which is like postural orthostatic tachycardia, where you stand up and feel dizzy, um, neuropathy, cancer, mitochondrial dysfunction, um, myocarditis, right? Like so many of those things can happen from other kinds of toxins too. We just haven't heard about those as much, but some people can have severe reactions, just like a vaccine injury, to mold. And it's the genetics underlying what makes us more or less likely to hyper respond or react to certain kinds of toxic things. And different people are going to react to different things. And so underlying health conditions were commonly seen to be exacerbated. So people that had, I'm going to come back to the genetics in 1 second, but people that had, say, dysregulated blood sugar became type 2 diabetic after the vaccine. People that had kind of high blood pressure, then needed medication for blood pressure. And so sometimes underlying conditions got worse because of the vaccine. And it's because it was a huge dose of a toxic thing that triggered the immune system to essentially freak out and overreact and cause this chronic ongoing inflammatory process. So with the genetics is super cool. And if any of you are ever interested in having your genetics done, I do this. So the nutrigenomics testing, so you do a cheek swab and send it in, and they look at 77 different genes, and it's all kinds of cool things that tell you your cardiovascular risk. Do you have to work a little harder to not have high cholesterol? Do you have to work a little harder to make sure you don't become type 2 diabetic, right? Some people, it seems, they can eat all kinds of sugar and then they never end up diabetic. And other people, you have a cupcake and then your blood sugar's off the charts. So there's genetic reasons why some people are more susceptible to different things. And in these 77 genes, some other fun ones are, do you have a snacking gene? Some people actually have DNA that makes them want to have snacks. And, that can have bad outcomes depending on the type of snacks. And, what's your circadian rhythm? How well do you break down caffeine? You know, so there's lots of cool things in there. But what I found after looking at a bunch of different people's genetics, the people that are kind of like the canary in the coal mine people, the people that react to either the vaccine or shedding, there's a lot of people that have hyper kind of vaccine injury like reactions without even getting the shot, but they react to other people that are vaccinated. So shedding is a whole huge thing. And so the genes that I have found to be the most commonly associated with people that have major reactions to any kind of a toxin are include these. So the MTHFR, if you have an inability to methylate properly, then you're not going to be able to detoxify as easily. If you have high underlying IL-6, IL-6 is an inflammatory molecule. So if your baseline is higher, then you're going to react more to any kind of toxic thing or infection or whatever. GST, so glutathione is one of the enzymes that helps us naturally deal with oxidative stress. Some people have a mutation that reduces that. So then they're going to react to things more because they can't make as much glutathione as someone else. And then there's superoxide dismutase, there's nitric oxide. Iron, some people genetically have higher iron, and iron is inflammatory. If you have high iron, you can actually just donate blood and that'll lower it. You might have to do it periodically, but it works. Some people have this FAD mutation. This decreases your ability to use omega-3, which is an essential fat. So you might need to have a higher amount of omega-3 supplement to make sure that your body's getting enough to be able to have that anti-inflammatory effect. And adiponectin is another gene that is related to your ability to um, basically have antioxidant effects to decrease oxidative stress. And then some people have a decreased ability to use vitamin E. So then you would need to take more or eat more vitamin E rich foods or supplement. And so when you have these kinds of mutations, and I found that vaccine injured have at least like 75% of these mutations. And then when I look at people that were vaccinated and didn't have any reaction at all, they don't have these mutations. And so I think that's kind of cool. It's a cool, interesting thing. So I think if you combine a crappy batch with some unfortunate DNA, then you're going to have symptoms and reactions. And I've also found that a lot of people that had vaccine reactions also react to other things. They're more likely to react to cell phones, to mold, to glyphosate spray on fields, to processed foods and plastic and other kinds of toxins. So if you do have reactions to things, you need to kind of avoid all toxins, right? Because it to help your body decrease that overall toxic load. So then the last thing I wanted to mention is nattokinase because blood clotting is a huge factor that I see in a lot of people that have inflammation. So cardiovascular disease is based on inflammation and damaging, your cells and your cell membranes in the blood that triggers this sort of clotting pathway. And so nattokinase is a cool molecule because it directly breaks down those clots. If you look at medications, anticoagulants don't break down clots. They'll prevent or reduce the production of clots, but they don't actually break down what's there. So what's cool about nattokinase and other proteolytics like serrapeptase and bromelain, they will break down clots that are already in the blood. And even on anticoagulants, we're always going to form some. And so these proteolytics will decrease, like actually remove clots from your blood. Whereas something like aspirin, for example, doesn't remove clots. It'll just like decrease any new formation of clots. So this is just details about how it works scientifically. But another kind of cool thing is these proteolytic enzymes break down the fibrin that forms clots and amyloid. So amyloid is like weird misfolded proteins that can be associated with Alzheimer's and things happening in your brain. Sometimes as we age, we, have a harder time breaking down stuff in our body. So proteolytic enzymes are actually really good for breaking down all kinds of weird proteins that shouldn't be there. Um, so this is an example of blood in a person that was prone to clotting. So morning fasting before they took nattokinase, and you can see all kinds of clots here. And you can see all this fibrin formation. Then they took nattokinase. An hour later, we looked at the blood again, and it's clear. So nattokinase works really quickly, and it's really great for getting rid of clots. So now, if you have a soy allergy, because nattokinase comes from fermented soy, then you can't take nattokinase. But serrapeptase and bromelain, those proteolytic enzymes are also great at getting rid of clots. So there's been a lot of arguments online about the use of nattokinase. In my experience, I think proteolytic enzymes are awesome if clotting or microclotting is your issue. So again, before huge clots, 1 hour later, gone. So that's kind of cool. An example after example. So clots, no clots. And again, and the other cool thing about nattokinase and bromelain both actually is it's been shown that they can actually digest spike proteins. So spike proteins are not evenly distributed in the body. They're inside of cells, they're sometimes in the blood, and sometimes they're on receptors like on cells. So spike proteins can be in a bunch of different places. But when the spike protein is in your blood, because that's where nattokinase can function, nattokinase can't get into your cells, but it can break down spike in your blood. And so that's pretty cool. And I can answer more questions about that if anybody's interested. And then the last thing, if you do want to take proteolytic enzymes, whether it's nattokinase, serrapeptase, or bromelain, you have to do it on an empty stomach. They are enzymes that need to stay intact and you can't digest them or they won't work. So empty stomach with a glass of water, at least 1 hour, preferably 2 hours before you eat anything. And then be careful if you're on an anticoagulant. Like if you have to take a medication that's an anticoagulant, then you want to be careful and work with a health practitioner like me. And, we can like work through all kinds of things and do blood work and stuff to make sure it's an appropriate supplement for you to take. Um, and then also you don't take proteolytics with any other supplement. So ideally you just take proteolytics by themselves first thing in the morning, and then they can absorb into your blood. Everybody is different, so it's difficult to, sort of say here's an overall kind of protocol that's going to help with inflammation, for example, because everybody reacts to different things in different amounts. Everybody reacts differently to different foods and supplements, and so it's really difficult. We can't just sort of say everybody should take nattokinase, right? So don't just willy-nilly take supplements. See a health practitioner like me if you have, symptoms and issues ongoing that you're trying to figure out, then I can help you figure out factors and things. So this is my website, dr-wendyhealth.com, and my email is there, and the genetic stuff is there, so you can click on that and then my heavy metal course. And yeah, the heavy metal course is really cool. And it's only $25. It's like 4 hours of like really cool content about, how toxins can affect us. And, even just simple things like where is it stored? How did like sometimes when we chelate, like we can't get into tissues. And then we have to think about our minerals. And then, we have to think about where is it coming from? How do we avoid it? And then what are supplements that can help? And so lots of cool information if you're interested.